Lesson 3.6, solving linear systems in three variables. We can use systems of equations in three variables to find out scoring systems for sport awards. You'll see a application for prizes at a winter fair, first, second, and third place. So it can be used to find a single solution to any system of equations. You need to have as many equations as you have variables. So 3 variables, 3 equations. When we graph a system of 3 linear equations in 3 dimensions, the results are shown below, where you can see no solutions would be an inconsistent system. One solution is an independent system, or infinitely many solutions, which is a dependent system. This can be very difficult to do by graphing, so we can use our algebraic methods of elimination and substitution to reduce our 3x3 system to a 2x2 system. So we're going to use elimination to eliminate one of the variables. And what you're going to do is you just pick 2 equations. So I'm going to pick equations 1 and 2, because if you take notice, you can see very nicely that the y can be eliminated if I add those 2 equations together. So I'm going to take equations 1 and 2. And like I said, I want to add them together because that easily eliminates the y. Okay, so that gives me one equation in 2 variables. I need to come up with another equation in 2 variables. So I'm going to choose 1 and 3. And I need to do the same thing. I need to eliminate the y's. So I'm going to leave the first one as is. And I need to multiply the third one by -2. And then I can add those. And now I have 2 equations in 2 variables. Oops, I didn't multiply that by -2. I made an error. When I multiplied by -2, I didn't change that to a positive 8. So this needs to be a 6, okay? So I have, oops. So I have two variables, 2 equations. So I need to eliminate another variable. This time I'm going to eliminate the x, and I'm going to multiply this equation by 3. Now I can add these 2 together, and I get z equals -1. Now I'm going to take that z and I'm going to put it in one of my 2 equations up that I just solved for earlier. So I'm going to put it in the -x one. To get -x plus 7 equals 6. So subtract 7. So x equals 1. And then I can put both of those in one of my originals. So the original I choose is the third equation. I'm just going to write down here since we can't see it. So I put x, I put my y, that's what I'm solving for, my z, 1 plus negative 2 is negative 1. So y equals negative 3. And then you write that as an ordered pair in 3 dimensions, which would be x is 1, then y is negative 3, then z is negative 1. These are relatively long problems, so they do take a little while. You have one to try. You have one to try. So pause the video, then see if you can make some sense out of solving 3 linear equations. Okay, you could also use substitution to solve a 3 by 3 system. Again, you need to do the same thing. You need to reduce the 3 by 3 system to a 2 by 2 system. And we're going to look at applications. Here's a nice sports application. Pretty much all you're going to do is create your X, Y, Z variables and write a system Okay, I chose to solve for y in equation 1, which is the first equation. So solve for y. And then substitute that into equations 2 and 3. In case you haven't recognized, I had a little error up there. Okay, so again, we're going to substitute into equations 2 and 3. I'm going to simplify these. These are now equations 4 and 5. Take equation 4 and solve that for z. And substitute that into equation 5. I'm going to solve that. I'll give you some shortcuts here. Then I can substitute that in. My rearranged equation 4. And I can substitute both of those in, or I can substitute that back into, also solve that x. Kind of missed that. You can put x here. This x equals 5 up into this equation to solve for y. So your answer would be 5, 3, 1. And you have one to try. You can choose whichever method you like. Personally, I like elimination. Substitution definitely gets to be messy. So try that, pause the video, see what you come up with, and then follow my solution. It may not be the same way you've chosen, but as long as you end up with the same result. Made another error. 9. Oh, wait. Oh. Do it again. And this ends 361.